If f is a function and r is a real number for which f of r equals 0, then r is called a real zero of f. Because of this fact, we can say the following four statements are true. R is a real zero of the polynomial function f. R is an x-intercept of the graph f. X minus r is a factor of f. And r is a solution to the equation f of x equals 0. If the same factor x minus r occurs more than once, r is called a repeated or a multiple zero of f. So we're going to find and list the real zeros of each polynomial function, then state the multiplicity of each zero. So for our first one, we have f of x equals 3 times x minus 7 squared times x plus 4. So we're going to set everything equal to 0, but 3 equals 0 is just kind of a throwaway, so we're not going to bother with that. We're going to start off with x minus 7 squared and x plus 4 equals 0. So we're going to set each one of these individually equal to 0. So I'm going to square root both sides here, and I'm going to get x minus 7 equals 0. And I'm going to add 7 over, x equals 7. Since this is a square here, that means that this occurs 2 times. That means we have 2 7s as a solution. So we can say this has a multiplicity of 2. And now we're going to do this one. We're going to subtract 4 over. We're going to get x equals negative 4. And because this is to the first power, we say that this has a multiplicity of 1, because it only occurs one time. Next, we have f of x equals x minus 6 cubed times x plus 9 to the 4th. Again, I'm going to set each one of these individually equal to 0. And now I'm going to solve. So I'm going to take the cube root of both sides, and I'm going to get x minus 6 equals 0. And then I'm going to add 6 over, and I'm going to get x equals 6. And because this is to the third power, that means there are 3 6s as our answer. So we can say that this answer of 6 has a multiplicity of 3. And now we're going to do the same thing over here. I'm going to solve for x. So the first thing I'm going to do is I'm going to take the 4th root of both sides, and I'm going to get x plus 9 equals 0. Then subtract 9 over, x equals negative 9. And since this is raised to the 4th power, that means there are 4 negative 9s as an answer. So we could say that this has multiplicity of 4. So 6 as a solution has a multiplicity of 3 because it occurs 3 times. And x equals negative 9 has a multiplicity of 4 because it occurs 4 times. Last, we have f of x equals negative 8 times x minus 1/3 squared times x minus 1 cubed. Again, the negative 8 doesn't really do anything, so we can just kind of get rid of it. And we can focus on the 2 factored parts. So x minus 1/3 squared equals 0. And x minus 1 cubed equals 0. So I'm going to take the square root of both sides for the first one, and I'm going to get x minus 1/3 equals 0. And then I'm going to add 1/3 over, so x equals 1/3. And since this is a square here, that means 1/3 occurs twice. So this has multiplicity of 2 because it occurs twice. Now I'm going to solve for this one. I'm going to take the cube root of both sides. X minus 1 equals 0. Then add 1 over. x equals 1. And since this has a cubed here, that means this occurs 3 times. So this has multiplicity of 3. Again, 1/3 is a solution with a multiplicity of 2 because it occurs twice, and 1 is an answer that occurs 3 times, so it has a multiplicity of 3.